Hi, Spring fans. I sometimes cheat. A lot of times I show people how to build things that work well in isolation. Sometimes I'll even build a bunch of modules and I'll just sort of leave them next to each other, sort of adjacent to each other, because I can open a bunch of them in their own IntelliJ IDEA window. I've got a very powerful machine. I can run Slack. I can run that, or I can run like 10 different IntelliJ windows, and it's fine, right? Or Docker and a whole Kubernetes, right? I mean, it's a really good machine. So I take some liberties that maybe perhaps I shouldn't. Usually I turn off the camera and I throw the demo away. It's just for didactic purposes anyway. But sometimes, especially for larger systems where there's interplay between components, between services, between modules, it's useful to see everything in a single place, especially if there's, you know, codependence between these components. Not to mention, it's just more memory efficient than having a whole bunch of different windows for each project. If I can load them all into one IDE, I'm not going to pay the cost of loading the Chrome and the engine and all that stuff for each IDE in a duplicative manner. Eclipse has always supported importing a bunch of disparate, otherwise unrelated projects into a single IDE so they can see everything in a single place. That's the default behavior, in fact. You logically group things into a Eclipse workspace, even if they live in different places. So here you don't really have that issue. I think Visual Studio Code can do this as well. I'm not sure. I don't use it for Java projects. I wrote my book in Emacs and Visual Studio Code. Asciidoctor is great there. But IntelliJ is not, historically it's been really painful to do that. And it's gotten a lot better now. Nowadays, you can just say idea space period in a directory, and it'll load the directory in a, and with all the subfolders below it, and it'll prompt you saying, hey, I discovered all these Maven builds or all these Gradle builds. Would you like me to load them as such? And so now you get the benefit of being able to see all the code in the IDE at the same time, which is great. Even that is an improvement, a marked improvement, but this is, I think, really great initially during fast and dirty development, but it also means that I've got redundant information, logical information about my build, redundantly stored across the different modules in the build. If, for example, I wanted to move all the code in lockstep from Java 17 to Java 21, for example, I would need to visit all the modules and update them individually. Again, for a handful of projects, this isn't all that big a deal. But it can quickly get out of hand, especially if you intend to work with a project for more than a day or two. Having that redundant build information, especially if you're iterating very quickly and you don't know what the shapes and the parameters of your build are going to look like, to have to figure it out and then make the change in 4 of the different places. It's not great. It's going to slow you down more than the convenience will have sped you up in the beginning. So you want to logically address that, especially if you can avoid the problem in the first place. You want to address that. I mean, after all, we don't like redundant information. It flies in the face of the DRY principle. Do not repeat yourself. We don't want redundant build information for things like plugins, for Java and SDK configurations, for dependencies, etc. There's got to be a logical way to centralize all this so that it can be updated and take effect across our entire build, across all the modules in the build. So you get the idea. We want multi-module builds as a logical way to store and centralize build configuration. So in this video, we're going to look at how to do that for both Apache Maven and for Gradle. This is a concept I think a lot of folks struggle with, and I've gotten countless questions over the years about this. And if I'm honest, I wasn't all that familiar with how to do it in Gradle myself. It took a fair amount of research and navel gazing earlier this year before I finally had a reproducible pattern that I would like to share with you here today. It turns out it's not super complicated. In fact, I think both systems, once you become familiar with them, make a whole heck of a lot of sense. They are really quite good. And I would argue the Gradle system is it's the better of the two approaches, but it wasn't intuitive at all. It's one of those things where while these two build systems have a lot of things superficially similar, the same sort of descriptions of dependencies, for example, the idea that you have plugins or tasks or whatever. There's some things that do not translate notionally, let alone semantically or syntactically at all. And this is one of those things where you're dealing with two totally different paradigms. So in this video, we're going to explore the basics of setting up a multi-module build for both systems. Okay, let's dive right into it. For our first example, we're going to build an application using Gradle. We'll go to start.spring.io. We're going to generate a project using Gradle and then basically hollow it out. We're going to gut it and use it as a foundational bit. So I'm going to call this a Beautiful modules. We'll just hit generate. We don't need most of it anyway. We've downloaded it. Let's go check it out. What you could also do, by the way, Gradle init, obviously. Here's our zip file. Unzip that modules. Okay, cd modules. And you can see we've got a source code in there. So that's the first thing we don't need right now. Okay, goodbye. Now, let's suppose that we have an application and a library, and we want the application and all other applications to benefit from that library. And we want all the libraries and all the apps to all share common dependencies. Okay. The way this works in Gradle is that you enforce this stuff through a plugin. So the plugin actually can provide these sort of foundational level setting capabilities, just like a Maven's dependency management, but it can do so much more. So we're going to go ahead and create a plugin in the build source directory. So let's create our modules. Let's say app library. Okay, I'm going to create two directories like this: source, test, main, Java, resources. And this is, by the way, a Unixy syntax. So make dir minus p to create a nested hierarchy of directories. And then I'm going to create app and library, both of which are going to have a source folder, and it's going to have a test main and a Java resources. Okay, so source test Java, source test resources, source main Java, source main resources. Okay, so if we do tree, we can see what we've just got ourselves. So we've got ourselves valid, source structures, but we still need a build.gradle for each of these. And speaking of, let's open this up. Okay, there's our new project. We're going to go ahead and gut all that. That's no longer needed. Okay, we're going to get rid of all that. But we can see what we want to do. We want to use Spring Boot 3.14 and the dependency management support and Java 17. So we have our directory for our apps and our library. The first thing we want to do is we want to tell Gradle that when it starts to build everything, it includes the modules that we specify. So we'll say include library and include app. All right, there. That's how we tell it to find the folders, so that it'll actually evaluate them during the build. But we haven't done the interesting part yet, which is how do we share and centralize information across these different projects? We're going to deploy a plugin. You can deploy a plugin like as an actual library. That's out of the scope of what I'm talking about here. Or you can have a project local plugin, kind of a special directory called build source that will be consulted for plugins that apply only to this particular build. So we'll do that here. Make dir minus p build source main groovy. So now we have this new directory structure here. We're going to put our Java and Spring Boot and all definitions in two different plugins inside this folder. Let's create source main groovy Java conventions dot groovy. We'll paste all that in. Get rid of that. There we go. So there's our Java conventions. We're saying that whenever we create a Java anything, whether it's a library or an application or whatever, we expect to have these dependencies present. Okay, and now there's a lot of stuff here, but maybe you want to standardize across your project. You want to use Postgres for everything. You want test support. You need JDBC. You need Spring integration. Maybe we don't need that for our thing right now. Maybe you want Lombok. No thanks, etc. Okay, so now I've got this specified in a single place. This is the configuration for Lombok, but I don't need that, so we'll get rid of that as well. And this specifies the bill of materials for the Spring Boot plugin. Okay, so that's the Java conventions. Now, we might also want to have conventions for applications. So these are the aggregation of other libraries. We would use the Java conventions for Java-based libraries. We might have another conventions file for Kotlin-based libraries. Applications themselves do more than just get published as libraries. We also want them to have the correct packaging as fat jars using Spring Boot's plugin, for example. So let's specify that conventions file. App conventions.groovy. Paste that in. Okay, so there's our app conventions.groovy. We're saying whenever somebody wants to create an app, we're going to automatically bring in our own library, and we're going to bring in these dependencies. But again, we're not specifying the version, and we didn't specify the version here. So that brings us to the next question. Where ultimately do the versions that are being used get specified? And that's in the build source build.gradle file. So it looks like that. No, here I'm saying I want to use the Groovy Gradle plugin, which is the Gradle plugin for building Groovy projects, including other plugins. I'm using the Gradle plugin portal, the repository, and I'm specifying the Spring Boot dependency management plugin that I want to use, the Spring Boot version that I want to use, the Java format plugin that I want to use, etc. And you can add custom plugins here. That's why I added this one. Is this is well, I mean, they're all custom plugins, but this one you might not have heard of. This one actually is great for formatting your source code, and you can actually specify it here, and then every module that brings it in will now have the ability to get its source code formatted correctly. We've got our build source. Let's go ahead and look at how to build those apps and the libraries out. So for this library, let's just create some source code here. Source main Java, and I'll create a new package, a new folder called library. And in there, I'll create a new file called greeter.java. We have a new greeter class that we want to share. Let's consume this now from our application. First, we need to define this build for the library itself. So create a new file, build.gradle. This is going to benefit from all the stuff that we've done to centralize that build logic. So we've created a conventions file for what it means to build a library. I can differentiate as I need to, but I can get 90%, or in this case, all of the configuration automatically derived from the name of the folder in which the code lives and the conventions file that we built earlier. Let's see that in action. So there it is. We're going to say, use this plugin called the Java Conventions plugin to do the work of building this library. Okay, that's it. Okay, so we've got build source. We've got a library with one single class that we're exporting. Let's go ahead and build a new app. We'll create a new folder. I'm going to call it app. Great with names. There's the folder. I'm going to create a new class called main.java. So new library.greeter.greet. Pretty simple program, but now, in theory, we should be able to open up the project in our IDE, compile and run the app, and then see the library doing its thing. Okay, let's try it. Okay, I'm using Java 17 for the build, but I've got Java 21 on my machine right now. This is a technicality of just Java at the moment. Doesn't really matter for you. Just make sure you're using Java 17. And then reload the build if this happens. You know what I did wrong? These are supposed to be called .gradle, not .gradle. Okay, so now we have IntelliJ has been updated to see the library in the app, and it knows the build source. So if I go to the app here, it knows about the code, but does it realize that it's a Java project, right? So we don't have a build.file here. I forgot to create that. So build.gradle. And I'm going to create plugins, ID app conventions. There we go. It's officially realized this is a Java project. It's realized I've got some bad grammar there for my Java class. Apparently, I have never used Java before. And run this. Ta-da! So there we go. Hello, library. Now we have a shared library being used by an app. We've centralized configuration. We've centralized dependencies. We've centralized build plugin configuration, and so on. So now I can just add more apps and libraries to the project, and I can reference one from the other. And of course, I can add other stuff to this as well. I can, do all sorts of stuff to further customize this. For a lot of apps, it might just be enough, and at least now I have a guarantee that I have the consistent version across the code base. And if I go into my terminal, I also benefit from shared plugins. So let's try this out. I look at the tasks. I've got tasks like the normal stuff that you get from Gradle, JavaDoc, the build from Spring Boot, all that stuff there, the boot run plugins, all that kind of stuff that I centralized is now available for me. I really like this approach because conceptually it's very clear. Everything is a plugin. And if you want to change something, you just create a new plugin. Gradle makes it super easy to build tasks and more sort of extensively plugins, which can be aggregations of other tasks and other dependencies. So plugins are very powerful. And here we're just using a local one. But of course, the logical extension is that you could take that same plugin and then publish it to your artifact repository. And it's basically the same thing. Now you consume that as an organization-wide conventional file. One of the nice things about this is I can package up and reuse plugins and dependency versions, right? In Maven, you only get one chance to do that, which is through inheritance. There are ways to bring in other plugins, but if you seed your one opportunity to do inheritance, you lose the ability for a plugin to level set or manage versions. And so the only place to do that is in inheritance. So let's go ahead and take a look at a Maven-based approach to a similar build. This is Gradle. We'll move our modules folder into Gradle. Now we've got this, get rid of the modules.zip. And now we're going to build a Maven one. And so same as before, we'll go back here, refresh. Actually, we'll just leave it as is. We're just going to choose Maven this time instead, but same basic configuration, nothing really special here. Copy or move modules here, unzip, cd modules, and you can see we've got, the source folder. We do not need that. We'll get rid of that. And we're going to create, same as before, we're going to create app and library, source, test, main, and Java and resources. So now tree. So there's our directory structure. We've got pom.xml. It's going to act as our parent. So let's go ahead and open this up, pom.xml. And we keep the dependencies that we want to share and version here. We're going to use modules to define, that the artifacts below us are the children of this one. And this is already kind of useful in of itself. So you can say app library. This means that even if the children don't know about the parent can still aggregate a bunch of other projects. So already this is kind of a useful thing in Maven. Like the child nodes can choose to be parented by a particular pom.xml or not. Okay, so we're going to define everything here as a module. Okay, we have the build plugin, but we don't really want that necessarily. Maybe you want that only for your applications. So we're going to get rid of that. We've got the dependencies. We've got the dependency management happening up here in the parent pom.xml. And then the packaging for this is going to be a pom, right? Not a jar. So we'll say packaging pom. Okay. Maven won't try and build a jar out of this root pom.xml. And then here, we're going to copy and paste pom.xml into library. And into app. And here we will specify that the parent of this is actually the root pom.xml. Okay, so we'll say relative path. Okay, 2 levels up. And it'll be whatever we named our thing. We named it Beautiful Modules. Okay, so we're going to call this Beautiful Modules. And it'll inherit by default the version of our parent. So our parent is parenting from Spring Boot. We don't need to specify the group ID because it's already assumed from the parent, but we do want to change this. This will be called app. Okay. App. Fine. We don't need the name either, technically. All right, there we go. So this is not a module, and the properties are specified in the parent, so we don't need to worry about that. And this, of course, is where you do want that plugin. Okay. So we've got app, and you could also create another pom.xml here called app, and then have all your other apps extend from that, right? This is how you would share app-specific configurations, by having another pom.xml. Okay, what about our library? Well, I'm going to copy and paste the app here. I'm going to call this library. Oh, actually, no. We already did have a version, didn't we? So let's go back to here. This will be inheriting from that version. That's fine. That's good. And we don't need this in the app, and we don't need that in the library. Okay, good. And there it is. All right, so now we have a library. Let's go ahead and add something to it, just like before. new package, new folder, library. We'll create a new class, greeter, public string greet, return, hello Maven libraries. Okay, I call that greeter.java, package library. Okay, pretty straightforward. Good, there's this. Now, what about the apps? Well, source main app, Java, new folder, app, create a new one, new class in there called main.java, package app, public class main, public static void main string args. System.out.println, new library dot greeter dot greet. Let's see if it compiles. So we go here, Maven clean package. Okay, so it understood that we've got two modules. We got modules, the root, and we got library and app. And by the way, this is where the name attribute becomes kind of useful. So, here I've got the name called modules, but maybe I want to make it more clear that there's a hierarchy. I can add this, I can reinstate this. I can say modules, library, or something like that, right? So this is the library, and then for pom.xml, in app, I do the same thing. App. So now I go back here, Maven clean package. There we go. So now it says modules, modules library, modules app. Okay, very good. So now, can the app depend on the library? Of course, right? So we go to the app. Where's our app here? Add a dependency, and here there's no special syntax for like project local versus sort of global dependencies. We just treat them like anything else. Okay, so paste all that. Actually, that's not true. There's one concession. I can use project.version, but whatever. Okay, and we want this to be library. That is a good question, actually. How did that work? How did I get the greeter from the library visible here? I don't understand how that worked the first time. Oh, I see what it is. This is packaged as a POM. Only the parent should be packaged as a POM. Everything else should be the default, which is jar. I could remove this, or, redundantly, I could specify explicitly that it's jar, but the default is jar, so that's rather redundant. I'll just remove it. Okay, now, if you try and compile the app without the library on the class path, it'll fail, okay? Because packaging it means compiling it, and that will not have compiled. So now we go here, clean, package. Okay, so unable to find the main class in the library. Okay, so the library main Maven build specifies the plugin. Well, it's not a Spring Boot app. It's just a jar that I want to consume as a library. Great, I'll remove that. There we go. Now we've got all the missing pieces. All right, everything compiled. Let's open it up in our favorite IDE. Looks like it's loaded all the code. So if I go to main.java, it sees it as a Java class. Fantastic. Let's run it. Okay, so there we go. We've got a main class that is able to depend on a library whose definitions, whose dependencies, and etc. are centralized because they're in the parent pom.xml. So we can put everything we want here, all the dependencies. We can take advantage of things like dependency management to centralize the single definitions of what versions of libraries to use. In this case, we're already benefiting from Spring Boot's dependency management for things like Spring Boot Start. But of course, if you have your own dependencies you want to level set that are not already specified by Spring Boot, you would put them here. We've looked at two different approaches for building multi-module builds. Hopefully you got something out of this. This is, just your desk check prerequisite for getting started with building and working in the Java ecosystem. There's a lot of power here, but sometimes people get lost in the the morass of the build itself and setting up that kind of structure. And I know I certainly was scratching my head trying to figure out how to do Gradle builds just a recent while ago. So one sympathizes. Anyway, hope this helps and enjoy your journey to production.